So here are a few examples where we're going to use this idea of factoring special binomials. So let's go ahead and look at this first one here. This says 27x cubed plus 8y cubed. The first thing we want to do is see if there's any common factors, and there are not. So now we think, are these perfect squares, perfect cubes? And we notice here, these are both perfect cubes. So this is 3x cubed, and this one is 8y cubed. And so we can look up here, we have a sum of cubes because it's addition, and so it is going to factor to 3x plus 8y, and then we'll have this part, so it's going to be a squared, ab, b squared, and remember our signs are same, opposite, so we're going to have a negative here and then a positive here, and we'll squeeze in what needs to go here, so this is a squared, so that's 3x squared, and then we have a times b, so 3x times 8y, and the last term is b squared, so we have 8y, and we want to square that. Doing some of that multiplication there, we have 3x plus 8y, and this is going to be 9x squared minus 24xy plus 64y squared. Coming to our next one, first thing we're going to do is look for common factors, and there are a few, so 7 goes into both of these. So 7, we have an x cubed and an x, so we have a common factor of x, y squared and y squared, so that's a common factor, and then a z in common in both. Well, what's left here if we factor those out? Factoring out of here, we'll just have an x squared minus 9. And we want to factor completely, so we look at this one. Here's a binomial. Does it fit any of our special difference of squareds, cubes, or sum of cubes? And it is, in fact, a difference of squares. So the square root of this is x, and then this is 3. So that can be our kind of our x and y here. So we have 7x y squared z. Keep that binomial there, and then it's going to factor into x plus 3 times x minus 3. Our last one here, we have a 2 in common, which leaves us with x to the 6th minus 64 y to the 6th. And is this a difference of squares? It is. Actually, this is a difference of squares. It's also a difference of cubes. We'll go ahead and start with this, and then once we factor using this, maybe we can go even further. So this is x cubed squared, and this is 8y cubed. Multiply together to get this, so we can do this difference of squares. So x cubed plus 8y cubed times x cubed minus 8y cubed. Well, this one's really interesting because both of these that are left fit these two things. So here's a sum of cubes. So we'll start this 2. I think I'm going to need a decent amount of room here, 2. And then this is x cubed, and this is 2y cubed. Same thing here. So I have my 2 out here, and then we have x plus y, 8y. So same sign. Then we have x squared. So we are looking at this right now because this is a sum of cubes. So we have x plus 8y and then x squared. Opposite sign, so minus x times 2y. And then plus, because it's positive, 2y squared. So that takes care of this one. And now we need to take care of this one. I'm just going to do a different color here. We're going to take care of this one in here. So this is a difference of cubes. So we have x minus y, 2y, and then x squared plus a times b, so that's x times 2y, and then plus b squared, which is 2y thing squared. That takes care of this one, and so let's write our final answer here. We'll go ahead and write that in red. We have a 2. We have x plus 8y, x squared minus 2xy plus 4y squared times x. You know what? This 8 is wrong. That should be a 2 coming from this. So this should be a 2. Hopefully you can see that. So this is x minus 2y, and then x squared plus 2xy plus 4y squared. And that's that one factored. So that one factors into several factors. 1, 2, 3, 4, 5 different factors.